You walk past a construction site. Cranes swing overhead. Engines groan. A single machine lifts a slab of concrete that would take 50 people to carry by hand. You barely notice it. It's just Tuesday. Now picture the same task 4,000 years ago. No engines, no cranes, no wheels in some cases at all. And yet the structure gets built anyway. Stones bigger than a bus end up stacked 80 meters in the air. The real answer to how this happened is far stranger than they had secret technology. They didn't need secrets. They needed people. Thousands of them working together in ways your modern brain has almost forgotten how to imagine. Start with the Great Pyramid of Giza. 2.3 million blocks, some weighing as much as 9 tons, built by most estimates in under 20 years. For a long time, that math didn't add up to historians. So they guessed. Aliens, lost technology, ancient super tools no one can find anymore. But then archaeologists actually asked the builders' descendants for help. Not literally, but close. In 1978, Egyptologist Mark Lehner teamed up with stonemason Roger Hopkins to try something radical. They tried to build a small pyramid using only tools available in ancient Egypt: copper chisels, wooden sledges, ropes made from plant fiber, human muscle. It was slow. It was exhausting, but it worked. Stones moved, blocks stacked. The myth of impossible without modern tools cracked open a little more with every log they laid down as rollers. Here's the part that surprises most people. The pyramids weren't built by slaves dragged in chains, as pop culture loves to imagine. Lehner's later excavations uncovered a workers' village near the pyramids, complete with bakeries, breweries, and medical care for injured laborers. These were skilled, paid workers. Some were even buried with honor near the monuments they built. Think about that for a second. The pyramid wasn't a monument to suffering. For many of the people who built it, it was a job. A hard one, but a job, with bread and beer at the end of the day. So how do you move a 9-ton block without an engine? Leverage, ramps, and an enormous amount of coordinated labor. Architect Jean-Pierre Houdin spent years studying the Great Pyramid and proposed something clever: an internal spiral ramp built into the pyramid itself as it rose, hidden from view once the outer casing stones went on. Instead of one giant external ramp stretching for a mile, which would have needed more material than the pyramid itself, the workers may have built the ramp up as they went, tucked inside the structure, turning corners as they climbed. Simple, efficient, almost invisible to us now. Is that theory proven beyond doubt? No. Archaeology rarely offers certainty, but it shows you something important. Ancient engineers weren't guessing. They were solving problems the same way your brain solves problems today, just with different tools in the toolbox. Now travel 4,000 kilometers away to a green field in southern England. Stonehenge. Sarsen stones weighing up to 25 tons each. Smaller blue stones weighing 2 to 5 tons, somehow transported nearly 150 miles from the Preseli Hills in Wales. 150 miles. No wheels suited for that terrain. No trucks. No horses trained to pull that kind of load in Neolithic Britain. So how? Archaeologist Mike Parker Pearson led the Stonehenge Riverside Project, spending over a decade tracing the bluestones back to their exact quarry origin in Wales. His research suggests the stones were likely moved using a combination of wooden sledges, log rollers, and rope, dragged over land, and possibly floated along rivers and coastlines for parts of the journey. It would have taken massive coordinated effort, possibly hundreds of people pulling in rhythm, chanting, resting, and starting again. Why go through all that trouble? Why not use closer stone? That's the question that haunts researchers the most. The bluestones weren't the easiest option, they were the deliberate one. Some archaeologists believe the stones carried spiritual or ancestral meaning, tied to specific places and specific people. Moving them wasn't just an engineering challenge, it was maybe a statement. A community proving something to itself, and to everyone who would ever stand in that field afterward. You do something similar today, even if you don't call it that. Think about the effort people pour into weddings, funerals, monuments, even elaborate birthday parties. Humans have never just built things because they were useful. Sometimes the effort itself is the message. Let's go somewhere even more mind-bending: South America, the Inca city of Sacsayhuaman near Cusco, Peru. Massive limestone blocks, some over 100 tons, fitted together so precisely that you cannot slide a piece of paper between them. No mortar, no cement, just stone against stone cut with an accuracy that modern machinery still struggles to replicate casually. How? Patience. And an intimate, almost obsessive relationship with material. Inca stonemasons are believed to have used a method called pecking, using harder stone hammers to slowly, repeatedly strike softer stone blocks into shape, checking the fit again and again against neighboring stones, adjusting fractions of a millimeter at a time. It wasn't fast. Some blocks may have taken months to fit properly, but once fitted, that precision gave the walls incredible earthquake resistance. Stones could shift slightly during tremors and settle back into place, undamaged, while more rigid modern structures nearby cracked. Notice the pattern forming across all three of these sites: Egypt, England, Peru, different continents, different eras, different materials, and yet the same underlying truth every single time. These civilizations didn't lack intelligence, they lacked shortcuts. And without shortcuts, they were forced to understand their materials on a level almost no one alive today experiences. A modern construction worker rarely knows the exact grain and weight and balance point of the stone they're using. Ancient builders had no choice but to know it intimately. Their hands were the machine. Their community was the crane. There's something almost uncomfortable in that thought. You live in a world engineered for speed, fast shipping, fast food, fast answers in seconds from a screen. And yet some of the most enduring structures on Earth were built by people who moved at what feels, to you, like an impossibly slow pace, stone by stone, season by season, sometimes generation by generation. The Great Pyramid still stands after 4,500 years. Stonehenge still stands after 5,000. Sacsayhuaman has outlasted earthquakes that flattened Spanish colonial buildings built centuries later right next to it with supposedly superior technology. Maybe that's the real twist here. Maybe impossible without machines was never really the right question. The stones didn't need machines. They needed time, patience, and enough people willing to pull the same rope in the same direction again and again until something outlasted every one of them. Tonight, when you scroll past another video about a building going up in weeks using cranes and prefab concrete, remember this: speed is not the same as strength. And somewhere in a field in England, or a hillside in Peru, or a desert outside Cairo, stones that were never touched by an engine are still standing, waiting patiently, the way they always have, for you to finally stop and ask how.